Okay, we're continuing section 1.4. This time we're going to compare some functions. So first up, this kind of looks like a lot going on here. I've added some other details, a graph and a table. So really what's going on is we have an f of x function and a g of x function, g of x right here. So we have this table versus this graph. And we're just going to compare different things. Notice it's all the same table, it's all the same graph. We're just comparing different details like x-intercepts, y-intercepts, slope, and so on. Just a couple reminders here. What you could do is sometimes it's hard to compare a table to a graph. So one thing I could do is take this f of x and plot a few points, like 0, -1 is about here, and 3, 0 is here. So it's some sort of line. I could plot some other points, get the picture. Or if I have a graph, I can make a table to try to match the table, the values they use. So I just try to figure this out from the table or come up with an equation for this. So you could make a graph or make a table depending on the situation to help compare a little bit easier. For example here, at x-intercept of f of x-intercept is when the y value is 0, so 3 must be my x-intercept for f of x, and g of x, I look at the graph, looks like it's at -2. So fx intersects x-axis at a point farther to the right. Especially with the picture, it helps. Here's my x-intercept for fx. This guy's way over here, so the fx x-intercept is further to the right. If you compare y-intercepts is when the x value is 0, so 0, -1 would be my y-intercept. You can also see it on the graph here. If I look at the graph here, it's at 4. So g of x intersects y-axis at a higher point. This one has a higher y-intercept than the f of x function. And last is slope. It's actually easier looking at the graph. This one goes up 2 over 1 for g of x. This guy, you either look at the change in the x and change in the y, or maybe it's easier to look at the graph. This looks like it goes up 1 over 3, especially if I look at some of the numbers here. So 1/3. You'd also see that this is changing, if we look at it here, where it's changing by 1, and the x's are changing by 3, so 1 over 3. You could also look at the pattern in the table. So each function is increasing. We can see they're both a positive slope and increasing, but the slope of g of x is bigger, it's greater. So g of x increases faster. You can try it yourself here, so feel free to pause and try it out. They just give us one table here for f of x, and g of x is on this graph here. Again, I thought it would be easier. This is supposed to be more of a line, so I tried to freehand it there, but more of a line here. I just plotted like 0, -2, and 1, 0, and drew my line. Now I can compare. G of x has a faster rate of change. Well, if anything, it's negative, and this one's positive, so I don't know about faster in that case. We can also look at the actual slope. This one goes up 2 over 1, whereas I think this one goes down 1 over 2. So 2 is already bigger than 1/2. By the way, select all that apply. The x-intercept g of x is greater. Let's see, the x-intercept's way over here versus just at 1, so yeah, that makes sense. The y-intercept of fx is greater. I don't know, the y-intercept here is -2. This y-intercept is +2, so nope, that's not true. Both functions are decreasing. Well, g of x is, but when we see that from the table or the graph, it looks like fx is increasing. fx increases while g of x decreases. Yep, that's what we just talked about. And fx has a faster rate of change. I would say yes, because fx has a slope of +2 versus just a slope of -1/2. You could also do these when they're non-linear. So again, sometimes sketching a picture just helps, get through all the questions here. So with fx, they get all this information, x-intercepts, y-intercepts, relative maximums and minimums. So I just drew a little sketch over here to the best of my ability. It may not be drawn to scale or anything like that, but I'm just going to use this as kind of a guide along with these values in here. This is definitely summarizing all the kind of main points there, end behavior and maximum, minimum, and all that. Let's see, the x-intercept of f of x is less than any of the x-intercepts of g of x. Looks like this x-intercept is definitely -3. All the x-intercepts here were a bigger number. The graph of g of x definitely intersects the x-axis more, has more x-intercepts. We only have one x-intercept here for fx. The y-intercept of fx is less than. So this here y-intercept was, only 1.5, whereas the y-intercept here is much higher. So therefore it crosses at a higher point. The relative maximum of fx is greater than the relative maximum of g of x. So be careful here, again, not drawn to scale, but I can see this maximum is at 4.7. If you count out, this might be like 4.1 or 4.2. So fx is bigger there. And the relative minimum of fx is actually greater. So this minimum is, I don't know, what they say here, 1.1, whereas this minimum's in the negatives. And what else we got? The two functions have the same end behavior. Both on the left side are going to negative infinity, and on the right side are going to positive infinity. That should wrap it up. So bring some questions, and we'll go from there.